Johann Carl Friedrich Gauss
was born in Germany on April 30th, 1777. He was born into a poor family. He was known as a child prodigy who was good at arithmetic mental math his whole life. He later then created a sequence that we will get into later.
Gauss has made numerous contributions to many different branches of knowledge, such as physics, astronomy, mathematics, and more. In terms of mathematics, a few of his contributions include number theory, geometry, a subject we all love, curves and probability, the theory of functions, and more.
Gauss made several important contributions to modern-day math. One of these contributions is the formula for the sum of an arithmetic sequence. When Gauss was around 9 years old, he was given a problem. The problem was to find the sum of all the numbers from 1 to 100. He split the numbers into two columns. One column had the numbers 1 through 50, the other column had the numbers 51 to 100. The second column was also arranged from largest to smallest. When these columns were vertically aligned, there were 50 rows, and each row equaled 101, which meant that there were 50 pairs of numbers that all equaled 101. From this, he created an equation. The equation was S equals n times the quantity of n plus 1 all over 2. The issue with this equation was that it could only apply to sequences with common differences of 1 and had an even amount of terms. Therefore, this equation was later tweaked. The equation we use now, S sub n equals n times the quantity of a sub 1 plus a sub n all over 2, is more inclusive.
One of Gauss's first discoveries was in 1792. The discovery was that a regular polygon of 17 sides can be constructed by a ruler and compass alone. The significance of this discovery was proving the analysis of the factorization of polynomial equations. His doctoral thesis of 1797 gave a proof of the fundamental theorem of algebra, which said every polynomial equation with real or complex coefficients has as many roots or solutions as its highest degree. Although his discoveries were not entirely convincing, it was remarkable for its critique of earlier attempts.
The fundamental theorem of algebra is applicable in the classroom because Gauss paved the way for the fundamental theorem of algebra to be defined as every nth degree polynomial will have exactly n roots. Let's go over an example. Here is a parabola. We know that the parabola is a second degree polynomial. We can see that the parabola crosses the x-axis twice, which means that the parabola equals 0 at 2 places. This means that we will have 2 roots.
Gauss died of a heart attack on February 23, 1855 in
Göttingen,
Germany at the age of 77 years old. He is now known as one of the 3 greatest mathematicians to have ever lived, along with the Greek mathematician Archimedes and the English mathematician and physicist Sir Isaac Newton. Gauss's contributions to mathematics aided future mathematicians and scientists, especially in the fields of physics and astronomy, in their own discoveries. Now, the fundamental theorem of algebra and the proof of the heptadecagon, or the 17gon, are now an integral part of many math classes.